When most of us think of a science lab, we think of test tubes, chemicals, and lab coats. This is called a wet lab. But wet labs and white coats aren't for everyone.
Well, my name is Juan Banda. We're at Stanford Center for Biomedical Informatics Research, and my position here is Data Science Postdoctoral Fellow. I'm actually from Chihuahua, Mexico. So I grew up in a city of around 1 million people. My upbringing was sort of academic in a way that half of my family, my mom had a PhD and she was an instructor at the university. So both my parents are engineers, civil engineers, so we were always doing math and all this. It was kind of expected. Well, I did mostly computer programming actually, since I was a very young kid.
Juan works with data, a lot of data. Every time a patient is cared for by a doctor, the results of their care are recorded. Juan sorts through all these cases and tries to make sense of them.
Well, the experiment here involves, you have a set of variables, a set of patients, and you want to figure out what is the propensity of that patient to have something or for something to happen. You don't set up an experiment like in a wet lab, but you actually set up, you get your features, your patient data, you build features, and then you train a model. These models, do statistics on sometimes hundreds of thousands of variables.
So what would it look like to the physicians, to the doctors in 10 years once your research and technology here is implemented?
Whenever they go and see the patient's history on their EHR system, they'll have multiple different buttons where they can say, give me patients like this patient. So they'll click a button and a lot of people will come up. They will put the patient in a category in a set, and then they will say, okay, this patient had a risk of this, responded to this treatment, didn't respond to this treatment. So it will allow them to see a better informed decision rather than just make, a very well educated guess. It's exciting in the sense that, you're answering real world questions, you're answering questions that many people have or that are very vital to other people to know. Where here, you have, internationally known experts on things that you're doing. So here, you don't just go and read a paper, and if you don't get it, you can actually reach out to the person, that developed this technique or this method and talk to them about it.
For the computer science community, this was a percentage of women in the professional fields of physics, math fields, and medical science fields from the 60s through the 70s and 80s, all the way to today. And computer science is the red line. And they're trying to explain why it's such a poor showing.
It's fast-paced, but it's also it allows people to grow faster and do stuff faster and more creatively, I think. I don't come in a day saying, I don't really feel like doing this. It's actually an ongoing process of, the day's over and I still have more things that I wanted to do. I don't have the biggest biomedical or biology experiences, but I have a lot of technical software engineering, software development experience that some of the people with a biomedical degree will not have. Also, you will never know everything, so there will be times where you're wrong. When you're teaching or when you're exposed to students, they'll see things differently, and they'll point out, things that you never considered.
I've been paying more attention into this area, this subcortical area, that often gets a little bit ignored.
I would definitely say try it. There's many aspects of research that you can do. There's many skills that it requires. You can't. You might not be the best technically proficient person, but with enough education, you'll know what to do.
That's why I kind of I always open them the same way so that doesn't happen. You always know where it is.
You don't need to be a super awesome programmer to run simulations and run what we do. Your strength can be writing, and you can still be a very vital piece in a research lab. So people have told me, oh, you can't do this, and I'm like, well, let's go and do it. So you shouldn't never be limited by what somebody else says about what you can and can't do. In research and science, you might not see an immediate impact. You don't see a shiny product, a shiny website that millions of people touch in a long time. But the feeling when you publish something that is worthwhile and somebody else cites it somewhere across the world that you've never seen or interacted with, that's very rewarding, knowing that your work is acknowledged by somebody else somewhere else. Also knowing that your work is going to go towards maybe a little grain of salt, but it's going to go towards maybe somebody will find it, make it better and use it for something good. Or maybe it's going to be a piece of something that put together will make good. So I think that that's, you know, the point of being in academia. If you really want to work for the greater good, to work on the cutting edge stuff and not being afraid of trying something different and new.